First, let me go ahead and make some introductions here. My name is Pierre Harry, and I am a product specialist here with Aviva Select California. And I am joined with two of my coworkers, Alcanza Cusa, who will also be presenting today. Alcanza, if you want to introduce yourself.
Hi, good morning. My name is Alcanza. I'm also a product specialist at Aviva Select California, based out of Irvine office. Thank you for joining.
Yep, thanks, Alcanza. And I'm also joined here by Annie Fink. Good morning, Annie.
Good morning, everyone.
So once again, thanks for joining, guys. And just to confirm, this is the PLC Connectivity workshop. It's the first one that we're teaching of this particular kind here. We're teaching it with the Rockwell PLC today. And so it's a follow-along workshop because we only have a single PLC to work with here. So unfortunately, this is not hands-on, but we will be showing you guys the communication link from the Rockwell PLC all the way to system platform and an OMI app that will show the tags that are being brought all the way from the PLC and that are being simulated from the PLC. And our goal today is to show you guys how easy it is to implement this communication link through system platform, so that if you use Rockwell PLCs and you're considering using system platform, you will see how easy it is to implement. And usually our workshops run about 3 hours here, but I think today, this will be a shorter workshop. So depending on questions, we'll probably run about half that time. So we'll give you the rest of your morning back. So without further ado, let's go ahead and get started. So the first step here is we wanted to show you guys a quick architecture diagram of our system to introduce how everything is coordinating, right? How the different pieces of the puzzle fit together here. So Alcanza, if you could pull up the screenshot here, we can show our diagram.
Can you guys see my screen to start with?
Yep, we can see it.
All right, you're seeing the desktop, right?
Yep.
Yeah, Zoom is not telling me which screen it's sharing.
No worries. And now we can see the diagram. So as you guys can see here, we will be working with a physical Rockwell PLC. It's a compact Logix controller that you can see on the left here. And we are using two VMs today. The first VM is the one on the top, 10.1.123. And the second VM is on the bottom, 10.1.121. So what do these two VMs do? Well, the first one is a VM that hosts Studio 5000. And for those of you familiar with Rockwell PLCs, you will recognize that that's the PLC programming software. And so if you're unaware of, Rockwell PLCs and use Siemens or Schneider PLCs, Studio 5000 is the equivalent to, if you use Siemens TIA portal, and if you use Schneider, it's Control Expert, right? So it's your PLC programming software. And we're using that on a VM to establish the communication link to the PLC from that PLC programming software to download the simulation code to the PLC and also establish the IO, right? And that's done through TCP/IP, as you can see in the middle. And it's an ongoing link between them where we're uploading data from the PLC and we're also downloading data to the PLC. So once again, the goal of that VM is to establish the tags that we will be bringing into system platform later, and then downloading the PLC code that simulates those tags to the PLC. Because we currently don't have any physical IO connected to the PLC, so we created a PLC program that simulates those tags directly from the PLC. So that's what that top half of the architecture does. Now, the bottom half is kind of the main juice of this workshop. It's the VM that hosts the system platform environment. And as you can see on this VM, 10.1.121, we are hosting system platform and the OMI app. And what it's going to do is it's going to gather the data from the PLC that's being simulated and extract it into system platform via the ABC IP driver. And that's the main focus of this workshop, is to show how to create and the ABC IP driver and make it work so that you can grab your data from the PLC into system platform. So thank you, Alcanza. Let's go ahead and go to the VM 10.1.123 that you can see here, and I'm going to request control. So thank you. For those of you that just joined, so this workshop is being recorded. We will also be creating a video, a more condensed video that will show all these steps. And we also have a manual that we can send out to you guys as well upon request. So all of these steps that you see here, don't worry, they will be documented in different forms. So just ask us at any time, after this workshop, if you want to revisit this, and we can send you either the video or the manual. So the first step in the Allen Bradley PLC connectivity process involves configuring the Allen Bradley Studio 5000 software, as I mentioned briefly earlier. And once again, that's the PLC programming software for our compact Logix controller. Our compact Logix controller is currently sitting in our Healdsburg office remotely, and it's connected to our network via Ethernet. So it will be communicating to this VM via TCP IP. So in this step, we will be writing the PLC code to simulate the field device values. And we're also going to define the IO mapping for these tags. This IO map is what we will use later in system platform to observe these values in real time in our OMI application to demonstrate the communication link from start to finish. So we're going to go ahead and open up the Studio 5000 software, which is on the bottom. There you go. And this is our Studio 5000 environment. So the first thing I want to show here, because all this is pre-built, right? I wanted to show you guys the IO here. So if we go to the controller tags area, this is where you define the IO inside of Studio 5000. So as you can see here, we have a pretty long list of IO right here that we're defining. But for this particular workshop, I want you guys to focus on the valve 1 VLV001 and valve 2 VLV002 tags. They're organized here by group. And as you can see, there's a lot of them, but for this particular workshop, we're only going to be using about 8 of each, and you'll see those 8 of each valve demonstrated in the OMI app later in this workshop. So the 8 that we're going to be using are valve auto command, valve manual command, valve auto status, valve open status, valve closed status, valve open indicator, valve closed indicator, and valve auto permissive. So don't worry about remembering those exact valves. I just wanted to valve tags. I just wanted to list them off here to show you guys which ones of this list we will be seeing inside the OMI app, because we're not going to be showing all of these, although we could, right? But we're just sampling a few of these tags in the OMI app to show that the communication link is working. So here is the IO map. And next, I wanted to show you guys the code right here. And I'm not going to go too in depth with these different programs because that's not the focus of this workshop. But I just wanted to show you guys that we do have some code here, right, that we implemented to simulate these valve values that I listed, right? And so you can see this is the main program for dev_VLV001. So this is the main program block for valve 1 that is simulating the values, because we want them to change inside of OMI to show that the values are being simulated, right? And so this is the code that is simulating those values and making them change. So now that we have the IO defined and the PLC code simulating said IO, the next step in the process would be to connect to the PLC, right? So you have your IO defined and your code, right? And in real life, you would actually have your physical IO connected to your PLC. So you would not need this simulation code here, right? Because you would have your sensors and your temperatures actually reading field values. So you wouldn't need this step. But in our case, we don't have those sensors and temperatures connected to the PLC. So we have the simulation code. But in your application, you would not need this step. All you would need to do is define the IO here to get started, right? And define the different IO points on the PLC that are connected to those sensors and those valves. And once that's done, you would go to the communications tab up here in the ribbon and select who active. And luckily, Allen Bradley makes this process pretty easy for you guys compared to some other PLC manufacturers. The way it works to connect to the PLC, you can just select this who active area right here. And if you're on the network, it will automatically scan your network for compatible PLCs. And so as you can see here, our PLC automatically populates right here. So that's the PLC that we're going to be using, 10.1.117.107. And this is, if you guys are familiar with Allen Bradley PLCs, this is the type of PLC that we're using. Once again, it's a compact Logix controller. And we're already online because we already performed these steps, right? But what you would do if you weren't online is you would go ahead and select it, highlight it, and then you would download to that PLC to download your configuration from Studio 5000 to the PLC. And then you would click on Go Online, and that would establish the communication from Studio 5000 to this PLC and download the appropriate code to it. So, once again, we've already done this. All these steps we've already done. We're just showing you guys the steps that were already performed and how we arrived where we arrived. But we wanted to show you guys, how you would do it if you guys were to do this yourself, right? So you would select the PLC, go online, and download to it. And you can prove that you are properly online and connected to the PLC by seeing these green indicators on the top left here: run mode green, controller OK green, and IO OK green. If there was a communication issue, those would be red or yellow. They would not be green. So all green is good here. So this pretty much wraps up the first lab of this workshop, right? Which is to, once again, to summarize, establish the IO that we're going to be using, and in our case, simulate the IO by using the PLC code, and connect to our physical PLC, download the simulation code to it, and go online with it. Does anyone have any questions about lab 1?
Iron way. Yeah, it's definitely the
sorry, I'm not understand. Did someone say something? I didn't fully understand that. Sorry.
I think someone has their mic unmuted, but I'm not sure if they're aware of that. You can always type in the chat if you have any questions or if the audio is not collaborating.
Yep, thank you, Alcanza. Philip, I saw that you spoke up. Did you have a question about this lab?
Yeah, I just have a quick question. I apologize.
Sure.
This is your guys's, or this is not. Is this Control Studio 5000, or is this your software here that we're looking at?
Yeah,
so
this is
designer Aviva Select at the top left. That's why I was wondering.
Yeah, no worries. So this is Studio 5000. Yeah.
Okay,
so
that's what I thought.
Yeah.
That's just what you titled it, correct?
That's the title of the program.
Okay, that's what I thought. Okay, just checking.
Yeah.
Yep.
Yeah, no problem. Great question, Philip. So yeah, just to confirm, this is Studio 5000. This is the Allen Bradley software, the PLC programming software that allows you to program these particular PLCs that we have, the compact Logix controller. And, I kind of went through this pretty quickly, right? This part of the workshop, because this isn't the focus of the workshop. The focus of the workshop is the connectivity to system platform. But we did want to mention that we use Studio 5000 to define the IO list that we're going to be using inside a system platform, and program the simulation code that will allow us to simulate those IO, because we don't have any sensors connected to it currently. All that is simulated via this program. Does that make sense, Philip?
Yeah, it does. No, I say I've worked with Control Logix 5000. It's been a few years, but it looks a little different. But I just wanted to make sure that this was Control Studio 5000.
Yeah, no problem. And yeah, this is the latest version, so it might be slightly different than the one you're used to. But yeah, this is Studio 5000.
Thank you very much.
Yeah, no problem. Great question, Philip. Does anyone else have any other questions about this lab? You know, again, this is not the focus of the workshop, but we welcome any questions if you guys have them.
What version of Studio 5000 are you using? Can you just show help about?
Great question. It's the latest, Elconsa, do you know off the top of your head? I'm not sure, actually. It's the latest one.
Probably
If you click on help and then about, it will show you.
33.
Thank you.
Yep, no problem.
Yeah, I wasn't familiar with the simulation block.
Yeah, so I'm not familiar with the different versions of the software and when different aspects were implemented, but it might be a newer feature if you're not familiar with it, Ray. I'm not sure, but this is, yeah, so this is the most current version of Studio 5000.
So appears in the upper left-hand corner after Logic's designer up there.
Yep. Correct. Awesome. All right. Well, thanks, guys. We're going to move on to lab 2 here. So Elconsa, I'm going to go ahead and stay in this VM for this lab, and then for lab 3, we'll move over to the next one. So so for this lab, guys, we wanted to show how you would install the ABC IP driver inside a system platform. Because when you install system platform, you might not automatically have it, and that could lead to some confusion. You know, we can move on to lab 3 and show you how to configure it, but you might then go into your system platform environment and not see it there. You might wonder why it's not there. And the reason for that is it needs to be specifically installed via the system platform installer. So for this lab, we wanted to show you guys how to install it.
You can just open the file explorer.
Yep.
It's already there. Yeah. Okay,
Yep,
that's
thank you,
installation. I think we have the 2020, the latest one, 2020 R2 SP1.
Yep, it's the setup right here. Yep, so thank you, Elconsa. So as Elconsa mentioned, in order to enable this feature, right, to unlock the ABC IP driver, you need to access your installer, so your system platform ISO file that you use to install system platform. In our case, we have system platform 2020 R2 SP1. We're going to go ahead and open up the setup module right here. And so this is the same setup module that you used to install it in the first place, right? And so all we're going to do is we're going to modify, because right now we already have it installed. And, you know, if you're installing from scratch, it's the same process. You're just going to be, you know, skipping this particular step because you don't already have system platform installed. But if you do already have system platform installed, you're going to go ahead and select modify and then click on next. Acknowledge new behavior, accept the terms and conditions. Click on next. And this is the bread and butter of this step here. Is right here in this step is where you select the different features and products that you're going to install with system platform. So this is the same dialog box that you see when you install system platform from scratch. And this is where, you know, you check off the different boxes of what you want to install with system platform. Now, what we're going to do is we're going to scroll all the way down to the communication drivers pack. And this is what you want to focus on here, because the drivers pack contains the different communication drivers that you can install. And these don't all get checked off by default, right? So in our case, we want to make sure that the ABC IP one gets selected. And in our case, it's already been installed, right? But if yours wasn't installed, you would check off this box just like this, and then proceed with the installer. Now, you'll notice that there's 2 Allen Bradley communication drivers, right? And the neat thing about the installer is that there's a little description box that indicates what these are, because they're not always obvious, right? And so basically it comes down to which, you know, PLCs they support, because Allen Bradley has different PLC platforms, different series, right? So ABC IP is the control logics, guard logics, compact logics, flex logics, etc. series, while ABC TP is the legacy platforms like PLC 5 and the SLC 500 Ethernet controllers. So in our case, we don't need the ABC TP. We're just doing ABC IP because we have a compact logics controller. But I wanted to show you guys the two different options here to show you guys what is possible with system platform, right? And that these communication drivers packs will support all the Allen Bradley PLC series.
Pierre, do you mind if I ask a quick question?
Yeah, go ahead, Chris.
If we have system platform already installed, how would we go about adding this pack if we don't have it?
Yeah, so that's the thing, right? So I can show you again how it works, but so we already have system platform installed on this VM as well.
Oh, I see. You just went to set up again and just install that specific pack. I got you.
Exactly.
Okay.
So yeah, so what I was trying to say is that regardless, you're going to go, if you don't have it installed or if you already have it installed, you're going to go to the setup in the ISO file, the same ISO file you use to install system platform.
Okay.
Yeah. And then if you're going to install it from scratch, you won't see this screen here, right? Modify, repair, or remove. It'll go immediately to the first step. But in our case, since we already have it installed, we're going to modify it, click on next, accept the terms and conditions, and then arrive at this next dialog box here, right? And then you can see the components that are already installed, they're checked off. And if your ABC IP driver is not checked off here, this is where you would now check it off and click on next and proceed with the installer.
Great. Thank you.
Yep, no problem. And so, as I mentioned, guys, we already have it installed here, so I'm not going to go all the way through with the installer, right? As you can see here, I didn't select any additional features, right? So I can't proceed with it. But if
Sorry to interrupt. Just to answer Chris' question, if you're asking whether this pack is included in the software installation, whether it's part of the license or not, I believe most of system platform licenses include the Aviva communication drivers pack, and these can also be purchased separately.
Okay.
But this should be in the installation files for system platform. If you have system platform license, most likely you have the communication drivers also.
Right.
And to answer Ray's question, the ABC IP driver is an Aviva product. It's part of the Aviva communication drivers pack. It's not a Rockwell software product. I hope that answers the question. Right, go ahead, Pierre.
Yep, thank you, Alcanza. So as Alcanza mentioned, the ABC IP driver comes with the standard communication pack. So if you get the basic system platform licensing package, you will have access to this. There are some other tiers for the communication packs. Alcanza, we were looking at this yesterday. What were the other tiers? There's two more, right?
Yeah, I believe one of them, the standard one includes all of the supervisory servers. So all of these ones that you're seeing on the screen, the Allen Bradley, the Siemens, the Schneider, the OI Gateway, you can scroll down. All of these are included in the supervisory servers, and they come with the standard Aviva communication drivers back. Then I think there is the professional, and that one doesn't have more drivers, but it has more features. And then there is a premier, and I think that one includes the telemetry servers.
Exactly. Yep. Thank you, Alcanza. But all the ones that you see here in this communication drivers pack list comes with the standard driver pack. Perfect, thank you. So that wraps up lab 2. We just wanted to show you guys how you would install the ABC IP driver if you don't already have it installed. So let's go ahead and wrap this up. Alcanza, can we move on to the other VM? So for those of you that came late, just to give you a quick recap here, we have 2 VMs. We showed a little architecture diagram earlier, but the VM we were in before contains the PLC programming software, Studio 5000, that we went over a little bit to show that that's where we define the IO and create the PLC simulation code to download to the PLC. And then now we're moving on to this other VM that has our system platform environment and our OMI app. And this is where we're going to be showing how we configure the ABC IP driver. So far what we went over is the PLC programming code and IO mapping in Studio 5000 and where to install the ABC IP driver. And we didn't show you guys how to install the ABC IP driver in this particular VM, because when you install it, we already have, you know, all of our Galaxy and the SMC open here already for you guys to save time. And if we were to go through that installer with all of that open, it would cause some issues. You would need to close all of that out. So that's why we showed you guys how to install it in the other VM where all of that is closed. Hopefully that makes sense.
Sorry for interrupting again. So basically, if you're going to rerun the installation, you're going to have to stop all the services and deactivate all the communication drivers. It will ask you to stop everything.
Yeah.
And for order for us to save time, we wanted to do that in another machine, so we don't have to stop everything, and then we have to reactivate the driver and everything.
Yeah, exactly. Thank you, Alfonso. So now let's move on to lab 3, which is the configuration of the ABC IP driver and the SMC, the meat and bones of this workshop. So we're going to open up the SMC. We already have our Galaxy created here, and we'll show you guys the Galaxy environment later and the OMI app later. But right now we wanted to show you guys the SMC because this is where we're going to be configuring the ABC IP driver to link our system platform environment to the PLC. And this will, once again, you know, establish that communication link to allow us to use and display the live PLC data in our OMI app. And before we start here, I just wanted to mention that all this information that we're going through here, you know, we have a manual for it that we can send out upon request. We'll be making a video as well. And there's also a manual created by Aviva that shows all the information related to the ABC IP driver, which we can share with you guys upon request as well. So plenty of information and documentation supporting this process here. So inside of the SMC, we're going to go ahead and expand the Operations Integration Server Manager, default group, local, Operations Integration Supervisory Servers, and we're going to confirm that the Allen Bradley ABC IP driver is in that list. So this is where you see the list of drivers that, you know, as we showed in the last step, were checked off during the installer, right? Which ones were unlocked? And as you know, go through the installer again and check off more of those boxes, you know, based on your own need, you should see the different drivers populate here, right? But if those boxes are not checked off, you won't see them unlocked. This is a common source of confusion. You know, we have some customers that, you know, have the standard communication driver pack, and then they open up their SMC and they wonder, hey, you know, why do I only see 2 or 3 drivers here? I thought I had access to all these drivers. Well, that's because during the installer, you didn't check off those boxes. So as long as you check off the correct boxes and enable those components, you will see them on this list here. So we're going to go ahead and expand the Allen Bradley ABC IP supervisory server here. This is our instance, oi.abcip.2. We're going to expand that, expand on configuration. And then what we did here is, in this level here is where you can select, you can create your different ports. And so we created our port here. And what these ports are is they essentially represent a single PLC connection. So this port right here, new _ ENB _ CPLX _ 000 represents that single Rockwell PLC that we have, right? And if you had multiple Rockwell PLCs, which you absolutely can, you would add a second port, one for each PLC connection, right? And when you create these ports here, I wanted to show you guys here, you can actually, there's different options, right? And you might wonder what these different connection options are. These represent the different types of PLCs. And, you know, each of these names is described inside of the ABC IP driver manual. But in our case, we wanted the ENB _ CPLX because that represents the compact logics controller that has the interface module as the PLC, right? So with the Rockwell PLC racks, there's 2 options. You can either have a rack that has its own interface module for the TCP/IP Ethernet connection, or one that uses the PLC itself as the interface module. In our case, we're using the PLC itself, and so that's the ENB connection. If you were using a compact logics controller and you were using a separate interface module, you would use the ENI_CPLX. So I just want to give you guys a quick overview of what these different options represent, right? It's based on the specific controller that you have, as well as whether or not you have an interface module or just the PLC. So this is the new connection here, ENB_CPLX_00. And once we dived in here and got this far, we want to start editing some of the parameters, right? So we told the ABC IP driver that we have one PLC connection here. And so the next step is to tell it where this PLC actually is, right? So we have to tell it where to look. And we do that by specifying the IP address of the PLC in the host name. Now, you might wonder, in this step, why do we show the PLC and not the VM, right? I've been asked this before in our previous PLC connectivity workshops and in general by certain customers. That a common source of confusion is why do we not point to the location where the PLC programming software is, right? Well, that's because we want to point to the PLC directly because we're extracting the data from the PLC and not from the PLC programming software. We're not grabbing the data from Studio 5000. Earlier, we only used Studio 5000 to map the IO and generate the simulation code that we then downloaded to the PLC. So remember, all of that information was downloaded to the PLC. So all we need to do is point to the PLC itself that has all the information that was configured from the Studio 5000, and we're extracting all the PLC tag data from the PLC itself. So that's why we're pointing to the PLC and not the other VM. So right here, right, point to the PLC, and then we're going to dive in further here. And we're going to create a new backplane connection. And then we are creating a new logics_CPLX000 connection within that backplane connection. I know there's a lot of steps here, but that's just how it's set up. There is no parameters that need to be configured for each of these steps, but that's just how the driver is set up. You need to establish the port, then the connection, a backplane connection, and then the specific instance of that backplane, right? And in this step right here is where you define some additional parameters. So right here, we're telling the ABC IP driver how the rack is set up, essentially, right? So we pointed to the PLC rack, and now we're defining how the rack is set up. So under slot number, we want to specify 0 because the PLC controller is located on slot 0. So we want to make sure that this matches where it lives on the PLC rack, right? Otherwise, this won't work correctly. And we want to make sure that these 3 boxes are checked off under tag database on the bottom: auto load tags, auto synchronize tags, and use persisted tags. They don't have to be checked off, right? I mean, these options are self-explanatory, but it makes our life easier, right? Because we don't have to deal with the different refresh rates or have to, manipulate some of these more advanced parameters, right? If we have auto load tags enabled, auto synchronize tags, auto persisted tag, or use persisted tags, it just makes the whole process easier. And I can't really think of, a situation where you would not want to use them. Maybe if you wanted some, greater control over the refresh rate and the synchronization of the tags. It's good to be aware of that these options are here, but for the vast majority of situations, you're going to want to have these boxes selected and these options enabled. So next, we're going to go to device groups. And this is a really important step because this is where you define the device groups that map how the tags are grouped together. And that's the device group that we're going to be pointing to in system platform. So this is a crucial step. It needs to happen because you need to organize the tags and device groups. And in our case, we defined a device group called topic 4. And, we didn't call it topic 1 because, just as an FYI, we have other drivers configured here that are using topic 1 through topic 3. So we just used the next topic that was in, numerical order. So that's why it's topic 4. And we left the update interval by default here, 1,000 milliseconds here. And so once again, this defines the device group for the PLC tags that we're going to reference inside of system platform. And with that being said, that pretty much wraps up lab 3 and the bread and butter of this workshop, right? So as you can see, I went through each of these configuration steps to create the ABC IP driver and diving into the different parameters that are necessary. And you might wonder, wait, this is pretty easy, right? Well, yeah, it is. It's actually a pretty easy setup. And we wanted to show you guys how easy it was to implement. One thing that I didn't mention before we move on to the rest of this workshop is that Alan Bradley offers an alternative to this. And some of you guys might be familiar, it's RS links. But in our experience, RS links can be a little confusing and convoluted at times and doesn't always work. I've had some customers complain about it specifically. And so a lot of customers are looking for alternatives. And that's kind of, the purpose of this workshop, and our goal here is to show you guys the Aviva alternative, right? Which is the ABC IP driver inside of system platform. And we wanted to show you guys how easy it was to set up. And as you saw in this lab, it's really straightforward, right? Once you have your ABC IP driver, installed, you just go ahead and create these connections and these backplane connections here, establish the IP address of the PLC, make sure all of your parameters are properly configured, and define the device group. That's it. Really simple process and easy to replicate.
Here, I do have a question if you don't mind.
Yeah, go ahead, Chris.
So the way we're set up at our site, we have like a series of VMs that we run different applications on, and we have one VM specifically for a system platform.
Yeah.
Would we create this port on the system platform node, or would we go to the node that is running the objects, the app engine?
That's a great question. So which node hosts, do you have an AOS node?
We do.
So it would be on the AOS node because that's
Gotcha, okay.
the application node.
Yep. Perfect. Thank
So
you.
without knowing your exact architecture, that's my first answer, right? I would have to look more closely to confirm that. But typically your AOS nodes are your communication channels, right? So you would go on those VMs and ensure that the SMC is configured there.
Gotcha. Perfect.
Yep.
I think we have a couple of questions in the chat, but I think they're coming directly to me. So first question is ISO SLC 500 available under the ABC IP? I would have thought that would be under the AB TCP legacy driver. So as Pierre mentioned, Ray, the PLC families included in each driver are listed in the installation process itself. As I don't know if you saw that, but there's a box to the right, basically next to each driver. When you click on each driver, it tells you exactly what PLC family is included. I'm not sure why is that not in the legacy driver, but that's how it is. And the other question is, can we learn more about those checkbox options, auto sync, persist, etc.? Not clear to me what they actually mean. So I think those are, I don't know, Pierre, if you have something to say there, but I think those are explained in great details in the ABC IP manual documentation, which we can share with you, Frank, if you want to go through these in details. So he's referring to the tag database.
Yep.
Options.
Yeah.
thank
so
you.
yeah. Go ahead, Frank. Were you asking a question?
No, just saying thank you for sharing the manual.
Yep, no worries. We'll share it with you guys. And yeah, just to add some more detail here, again, you'll find more detail than what we can offer inside of that manual. But these checkboxes essentially refer to, the refresh rate, how that connection to those tags is refreshed, right? If you don't have the auto load tags checkbox enabled, for example, you won't automatically load the tags, right? And so you'll need to do that manually. And the auto synchronization also has to do with constantly refreshing, right? And those tags. And you can actually see under device groups, you have an update interval provided here, 1,000 milliseconds. And so if you don't have the auto synchronized tags checkbox enabled, it won't leverage this update interval and check every 1,000 milliseconds if those tags are changing. And I'm not exactly sure about this third box, but once again, we'll send you the manual here, and that will explain everything. So does anyone else have any more questions about this lab before we move on to the OMI app? Awesome. I'll take that as a good thing. I think it's just, it's good because it's indicative of how straightforward this process is. And once again, that's kind of the goal of this workshop. Is it can get a little overwhelming at times, and you might think that this is a confusing and complicated process, but we wanted to demonstrate to you guys how easy it was with the ABC IP driver in system platform, and how, in my opinion, it's superior to the RS Links option that Rockwell provides. So without further ado, I'll hand this off to Alcanza for lab 4.
All right, thank you, Pierre. So, all right, the next step, I have a proposal here. Let's go over the O2 build part first, and then take a 10 minutes. How does that sound to everyone? And then we'll come back and continue working in system platform. So at this point, what Pierre did here is he configured the communication driver. The next step would be going to the system platform part or the ID and configuring the communication part here first, and then creating the objects, the attributes, and then creating the OMI app, and then eventually towards the very end, we'll have a look at the finished OMI app. But before we do that, I wanna give a demo of how to utilize O2 build first. That will take about 10 minutes, maybe 15 minutes, and then we can go on a break. So let's do that. So it is best practice to utilize a scrap galaxy when you're working on O2 build. And the reason for that is because you never know what's gonna be resulting out of the O2 build process. How the templates look like, it's going to create a DI object. You might need to basically configure those templates or change anything in the communication port. So it's always a better idea to do it on a scrap galaxy instead of doing it on your production galaxy. And this is what I'm going to do here. So this is going to be what to build this. Let's hope I don't have a galaxy under that name. There you go. So I'm building a new galaxy here just to utilize the O2 build on it, and then we'll go back to our normal production galaxy. Meanwhile, I'm going to jump back to the other machine where I have PLC software basically. So the first thing you need to do when you're utilizing O2 build is to save the program as a specific file type, and I'm going to do that, and it's going to be the .l5x, right? This is the file type that we're interested in, and this is what's going to be used in the offline mode process for the O2 build. So I've already saved that before. I didn't make any changes on the program after I've saved them. So, but this is where you would do it. You would save the program, and then you utilize this this file in the O2 build, basically, right? Now, once we've saved that file, I have this file here on this desktop. I've created the galaxy. We're going to connect to this galaxy and going back to the SMC. So you've probably seen the O2 build tab here in the ABC IP driver. Right, which is the last one here. So one thing to know here is that the online mode and the offline mode are both available for the Allen Bradley drivers. So they're both available for the ABC IP versus for the Siemens, driver, which I think is called SI Direct, I believe. Only the offline mode is available. So the auto build feature, or the Aviva auto build feature, is only available for Allen Bradley and Siemens PLCs. For this one, we're going to use the offline mode, and I'm going to browse for that file that we've saved, which is the .l5x. Just going to click on that. It's sitting on the same machine, and I'm going to upload it. And then I'm going to use the Galaxy name of the new Galaxy that I just created. I'm not going to use this Modic and WS Galaxy because that's my production Galaxy. So I'm just going to work on the scrap Galaxy first. And then the device group, I'm going to say topic 4. And then you can always add a prefix here if you wanted to say something like PLC5 dot the template name or the instance name. This is going to be a prefix before the template and the instance's name. I'm not going to add that. I'm not interested in that at this point. And then I'm going to go to the next step. And in this page here, auto build shows you, or it basically gives you a warning that these specific templates and instances will be skipped just in case there is some sort of error for whatever reason. Auto build cannot create these instances or these templates. My list is empty, so it should be okay. I don't have any problem here. So I'm going to go to the next step. And in the next step, based on that file that I've just uploaded, it basically looking at the PLC schema. It's looking at the PLC program that we have running. And it found a bunch of UDTs there that we're interested in. So if I just go back there for the sake of clarity. As you can see here, we have a valve UDT and we have a motor UDT. And these two are basically what we're interested in, specifically the valve UDT, and it's a UDT stands for user-defined type or user-defined template. And this is basically what's going to be showing in the auto build. It's going to be what it's looking for, and we're going to create our templates from there. I have 2 instances under this UDT, the valve UDT, which are valve 1 and valve 2, as you saw earlier here, right? So we have the valve 1 and valve 2. So going back to the system platform machine, I'm just going to say display templates with instances only for now. Just if you have a lot of templates here, it might be easier to utilize these filters. And I'm going to say I'm interested in this valve UDT. Now, because this valve UDT is using another template, which is the timer template, I am unable to unselect this. If I try to unselect the timer, it's telling me the template is referenced by another template, which is checked, which is this one. So because the valve UDT uses this timer, so I cannot uncheck it unless I uncheck the valve UDT, and then I can uncheck the timer. But once I check the valve UDT, the timer will be checked. And then at this point, I can choose the elements that I'm interested in. These elements in the PLC will translate into attributes in system platform. So we're actually not interested in everything. You can always obviously export everything, but I don't want to do that. So I'm just going to do some of them, I think 8 or 9 of them that we are using. So there's the closed status command, and then indicator open status. And I think there's a manual, let's see, right? 8 or 9 attributes only. So now I'm saying I want this template to be created in system platform, and I only want these 8 or 9 elements or attributes to be selected or exported. It is also best practice not to do it all at one step. So maybe I want to unselect these instances for now, because I want to make any changes in the template, and I'll show you what I'm going to do in system platform now. So we're just going to go to the next step, and I'm going to unselect these instances, and then I'm going to come back and import them into system platform. So I'm going to go next, and this is just a review of what is selected here, the templates and the instances. And I'm just going to say start building now. So my program is pretty, it's pretty small, in fact. So it's going to finish really quickly. If your program is heavier than this, or if you're creating multiple templates, it's going to take longer, but it's always a good idea to look at this, to monitor this window, because it tells you if something is stuck somewhere, or if you have an error somewhere, basically. All right, so it's saying that everything is created. I'm going to go to my Scrap Galaxy and look at the derivation to see if I have that template created. It's going to be user defined. There you go. So this is the valve UDT template. So this is the Galaxy that we just created together, right? The auto build does. And this is the valve UDT, and this is the timer template. I'm going to double click on this because I want to make some changes there. All right, so these are the 9 attributes that were selected at auto build. And they come basically with some default features, like the IO feature is checked for all of them. For example, let's say I wanted to say I want to historize this, the auto command and the auto status. I want to historize both of these. And I'm going to save this and close it. And then I'm going to go back to auto build to export the other 2 instances. So here I'm going to go back. And I'm going to say, please include the 2 instances, valve 1 and valve 2. And the reason why I'm doing this in 2 steps is because if I didn't do it in 2 steps, those 2 historization features for the auto command and the auto status will not be included in the instances. I was going to have to do them one by one, or I was going to have to do them at the template and then have to redeploy everything. So it's best practice to do instances at basically as a second step. So now I don't need to change anything here. It will take into consideration whatever changes I made to the mother template and system platform, and it will copy or it will export the instances with their attributes from the PLC. So I'm going to the next step. I'm just going to say start building now. There is, I think, a video on our channel that we've just posted this week, or we're about to post, that goes through auto build, same steps as I'm going through here. So if you guys want to have a look at that later, I think we can share the link with you. So no, I already done that. So now I go back to system platform. The 2 instances should have been exported. As you can see here, there is a plus sign next to the valve template. And if I click on that, I can see valve 1 and valve 2. So the 2 instances are exported. I'm going to double click on valve 1 just to see if the changes I made on the template are implemented here as well. And as you can see, these are the 9 attributes that we've chosen. And the changes that I've made on the auto command and the auto save, which is the historization feature, are implemented. So this is the purpose of doing it as 2 steps, basically. Notice here that it also created the DI object for us. It created the timer template, which is referenced in the valve UDT. So let's say you want to make any changes here. You want to wizardize this template. You want to add more attributes or delete some attributes. This is the right place to do it. Once you're happy with everything, you can export these templates and these objects basically and import them into your production Galaxy. That's best practice. You can always do it in your production Galaxy. It's just, I think it's easier and cleaner this way. So this is one way to do it. We are going to look at the other way to do it, which is doing it manually, basically in system platform. So we're going to go through creating template and then creating all the attributes and then creating the instances in our production Galaxy. And that's just another way to do it, basically. I think this is a good time to stop for a break. Let's take some questions first, though. If you guys have any questions about auto build, I see stuff in the chat. So one more time, auto build is used to create templates and instances in system platform based on the PLC program or the PLC schema. And it supports Allen Bradley and Siemens PLCs. It doesn't support Schneider. I think Schneider has their own tool. I think it's called Asset Link that does pretty much the same thing or in a similar way. And the one thing to note here is that OI Gateway does not include AutoBuild. I don't know if you have any questions about AutoBuild, if you're familiar with it. And again, I think we have a video that describes the process in detail. So if you want, we can share that link with you.
Conso, what license enables AutoBuild?
Hold on, I know that one. I think I've seen that yesterday. Hold on, just give me a second. So that's part of the communication drivers. It's part of the ABCIP communication driver and the what is it, the other one? The SI Direct, which is the Siemens one. So
Okay,
this,
so yeah, that's correct. Just to elaborate for the rest of the folks, for our communication driver licenses, there's different tiers or levels. And so there's the standard tier, which I think most of you folks are probably familiar with. The professional tier of the communication drivers gives access to the auto build feature. The other thing that it allows you to do is create multiple instances of an OI server on a single node. So that's the other thing that it enables, but
Oh,
so
yeah.
it would be the professional version of that license.
yeah, it's the professional version. It allows you to create the driver multi-instance and driver multi-version and the AutoBuild, correct? All right. Well, we can take questions after the break also. All right, there's a question. I'm an InTouch Edge user. Is there more customers that want to see this in an Edge format? I would be interested. Yes, Britt. We are actually thinking about creating similar PLC series for Edge also. It's not currently planned yet. It's an idea that we're thinking about. But we'll make sure that you're invited in case we have an event talking about Edge to any of the PLCs basically.
So
All right.
Brett, also for Edge, it's likely that you probably wouldn't use these communication drivers because the built-in drivers that come with Edge, including the ability to use, the ABCIP protocol through Edge. So there is the ability to pull in tags from the Edge controller. It works differently than you see here in AutoBuild, but there is the ability within Edge to pull in those tags from the controller itself as well.
Okay, let's go for a 10 minutes break. Does that sound like a long enough break? Short? Too short? I think 10 minutes is good. We've only been going for an hour, and then we'll go for another 45 to 50 minutes and probably wrap up by 11 o'clock. So I'm just going to put that in the chat so everyone knows where we are.
Yep. Thank you, Alfonso. And during this break, we'll stay on. I'll stay on if anyone has any questions about any of the labs that we went through so far. I know we had some late arrivals. Did anyone have any questions about what I showed earlier regarding the PLC software, the connection to the Rockwell PLC, or the installation and configuration of the ABCIP driver?
Is it possible just to brief how you started with?
To summarize what we went over so far?
Yeah, in the first 1 or 2 labs, I think I missed. Or
Yeah, I can actually, Alcantara, do
Just-
you want me to give you, here, you can give me control.
Yeah,
I'll briefly go back to the other VM and back to the SNC of this one.
Thank you.
Yeah, no problem. So was this Jacob who asked this? Sorry, I'm not sure. Okay.
Matthew.
Oh, Matthews. Hey, so Matthews, yes. So this is what we did. Initially, I went over, we have a VM that is hosting Studio 5000 that is directly communicating with the PLC through TCP/IP. We have a Rockwell PLC compact Logix controller in our Healdsburg office right now that's connected to our network via Ethernet. So we have this VM that is communicating with that PLC. And the way we set this up is, I'm not sure if you're familiar with the Rockwell PLC software, but this is Studio 5000 where all of that is configured. And we set up the IO map right here to define the tags. And we also have a PLC simulation code running here that we created in order to simulate the different tags because we don't have any physical sensors connected to this PLC. So we're simulating the field values essentially using this PLC code. So we established the IO map and then created the simulation code here. And then what we did is we downloaded all of that to the PLC and went online with the PLC that you can see right here.
Okay, yeah, setting up all the Logix or Rockwell PLC initially.
Yeah, exactly. So that's one thing I mentioned is how this is really neat thing about Studio 5000 is that it automatically searches the network for all the compatible PLCs, and it was really easy to connect to it, right? So we found the PLC on this list, downloaded the IO map and the PLC code to it, and then went online with it. And that's all we did with Studio 5000. And then after that, what we did is, Alconsta, if you could hop over back to 121. We went to our other VM that hosts system platform because they're on different VMs here. And what I showed was in the SMC here, how we configured the ABC IP driver. So it was pretty straightforward, right? We enabled the ABC IP driver in the installer, in the ISO installer file for system platform. And then we created a server instance. Sorry, go ahead. Did you have a question?
So if you wanted to enable the ABC IP driver, do you need a separate license for that, or it comes?
Yeah, so that's kind of what we were discussing here. So actually, I shared a file here in the chat that shows the different communication driver tiers.
Okay.
And with the standard communication driver tier, which is the lowest tier you can go, so you're going to at least get that one. You have access to all of these supervisory drivers. So you have access to the ABC IP driver by default. But as you can see on, in that image, there are some other tiers that unlock other functionality. But as far as the ABC IP driver is concerned, that will come with the standard communication driver pack. And I kind of, I could go over it again, but basically to enable it, you just need to go through the installer and check off the box for it. And at that point, it will show up in this list right here under the OI supervisory servers list. And we created an instance, created a port, and the port references specific PLCs, right? So this is our compact Logix port that references that connection. And we indicated where it was. So that's the IP address of the PLC. And then we created a new backplane connection here where we enabled some of the parameters here to make it work. And then define the device group. And that's the device group that organizes the PLC tags from the PLC that Alconso will show that's what she will be referencing inside a system platform.
Got it.
And that's pretty much it. I mean, again, it's a very straightforward process, right? And I just wanted to, kind of shed some light on the process because, we've had a lot of questions from customers who might be confused and overwhelmed because, the SMC is it looks pretty overwhelming, right? There's just all these these parameters. There's all these different ways that you can, you know, all these different things that you can change, and that can be very overwhelming at times, right? But I just wanted to show you guys here how actually straightforward this particular process is, you know, despite all the different options that are here. And one thing I mentioned to Matthews, I'm not sure if you caught that, but Rockwell has RS Links, which is an alternative to the ABC IP driver. But you know, in my experience, it's a more, you know, complicated process than the ABC IP driver here. That is the Aviva version of RS Links. And so we just wanted to show in this workshop that, you know, we believe that the ABC IP driver is superior to RS Links, and that is the way to go. And it's easier implementation.
Got it. Yeah, I've been using Alan Bradley's Rockwell Factory Talk Gateway, which I'm trying to send data to our cloud platforms.
Right. So you're using RS Links, right?
No, it's not RS Links. It's called Factory Talk Gateway. It's much more advanced than the RS older. They are trying to get away with RS Links. They're going with something called Factory Talk Gateway.
Gotcha. I don't have experience with Factory Talk Gateway, but you know, in my experience with these things, you know, when it's, you know, how am I going to phrase this? The software component that is provided by Alan Bradley, the way it's designed is it's not streamlined for system platform, right? So RS Links and Factory Talk Gateway, they're built by Alan Bradley to make them compatible with different, you know, OPC servers and different, you know, end softwares, right, to communicate to. So it's open-ended, and as a result, there's more configuration that needs to happen. But the ABC IP driver in system platform is specifically built and streamlined for the Alan Bradley PLCs, right? So, you know, in my opinion, it's better to go that route because the process is streamlined. It's set up specifically for this. Meanwhile, if you had to go through RS Links, there would be more configuration that needs to happen because there's just more, you know, there's just more parameters that need to be configured, right? So hopefully that makes sense. That's why I think the ABC IP driver is much easier, you know, if you're trying to use system platform with an Alan Bradley PLC.
So all this, so I can use even OPC from other platforms also in here, in the SMC.
What do you mean other platforms?
Okay, so if I wanted to get data from another source, like I use Labby also, maybe through OPC or.
Is that another Alan Bradley PLC?
No. It's another platform, like any like test systems and things like that, which is in the process.
Right.
So
Yes. Yeah. Yes,
so
you can. Yeah. Not with this driver though. You would not be using the ABC IP driver because this driver is specifically for the specific Alan Bradley PLC platforms that were listed in the description earlier. And I could send you that list, but Alcanza is showing here the OI gateway here. Right there is, you know, using the standard gateway and the OPC ports there. That is where you could configure that OPC connection to the platform that you're referencing.
Got it. So yeah, I've seen that the plugin for OPC in the previous one.
Yep. Yeah, exactly. So the answer is yeah.
Yeah. And
yes.
so do I need to pay extra for all this, or my question?
Do you need to create extra? Sorry, what do you mean by that?
Do I need to pay for each of those plugins, or it comes along with the SMC?
Oh, do you need to pay for it? No. Yeah. So the standard gateway comes with the SMC, the standard communication pack.
Got it.
Yeah, and again, I sent you guys in the chat here, Matthews. You should check out the image I sent here a few minutes ago. It shows the different tiers, and so by default you'll get the standard tier, which will unlock everything that you were asking about here, and Alcanza is sharing it. But there's 2 additional tiers that unlock some further functionality. But based on what you're requesting, the functionality that you're requesting here, that would come with the standard tier.
Got it.
Right, so up here is referring to the access to all supervisor drivers, and this is the list of the supervisor drivers. So PCUA is one of them, then MQTT and
So
Modbus
OPCC,
Uh-huh.
OPCUA, so that is along with the standard.
Yes, with the supervisor
Yep.
driver.
Okay.
Oh, Constance, going back to the auto build, when you created that, what is it, L5X file, it basically just captures all the tags within the PLC logic and it creates the objects for them within Wonderware, correct? That's the basic function of it. So how did it distinguish that there were two valves or two instances to create the objects underneath? I think I might have missed that when I was looking at your logic.
Yep. Hold on. Let's go back. So here. So you're asking, how did it know? So I'm browsing again for that file. So basically we saved that program, that PLC program as a .L5X.
Do you mind if we go back to that program? I just want to see the breakdown, maybe. And I guess when you first did it, before you before you created the instances, were they creating template objects or were they creating derived objects?
Sorry, can you ask that question again?
And maybe I was wording that poorly. The first time you did the auto build, did it create objects or did it create templates?
No, I only chose for it to create the templates. I specifically unselected the instances for a reason.
But you
Gotcha.
can do
So
both. You can
then
do
you
both.
modified your templates, and then when the instances were created, the changes that you made to the template level was carried over to the instances.
Correct. It takes into consideration whatever changes you made in the template. The change that I made, it was very simple, but you can always wizardize the template, and that makes it a little bit more complicated. But it will still take it into consideration when it creates the instances.
Okay. All right. I think that makes sense to me then.
All right. So yeah, just to answer your first question, we figured out not where the instances are, where derived from, basically.
I see.
We saved this entire program as that specific format.
So is it fair to say that a task within Logix Designer is equivalent to a instance in system platform?
Task.
And that the tag names would be the objects?
So I'm not sure, like the naming here is a little bit confusing, but a UDT is equivalent to a template, I think. I don't know if Tim is still here. Tim, maybe you can correct me. I'm not a PLC expert, so I'm not sure about the naming convention, but I believe a UDT is a template, equivalent to a template, and then the elements, or what we call elements, which are these tags here, are equivalent to attribute.
Oh, actually, that makes more sense than what I said. Yeah, I see that. Okay. Thank you.
Sure.
So Chris, are you using Rockwell PLCs right now? Is this a process that you could see yourself using?
In fact, we're trying to convert all of our systems to Rockwell PLCs. We're currently using quite a few LabVIEW C-RIOs, and for many reasons, they're just not really good for our shop site. So yeah, I definitely see myself using this quite a bit the next coming couple of years.
Gotcha. And you guys have system platform as well?
Absolutely. Yeah, we're on 2017 R2, but we're working with Aviva right now on a Galaxy review so that we can kind of tidy things up and then make the transfer over to 2020.
Gotcha. Well, this workshop's perfect for you then. I mean, hopefully,
absolutely.
Yeah, hopefully it showed you how easy it is. And I think in your case, auto build will save you a lot of time.
I'm excited about that. Yeah, it was just, so there's another one on this meeting as well, Rick Rudolph. He sits next to me and we were both just kind of quickly chatting, saying this is, seems a lot easier than we first initially thought, and might even save us a bunch of time when we do take the time to convert these systems over. We'll start with the PLC and just kind of auto build everything over to Wonderware.
Yep. Yeah, especially that you're starting with fresh PLC, so everything's going to be implemented with a convention.
Mm-hmm. Right.
It starts with a PLC. If it's built, if the program is built properly, then using auto build is a breeze. It can save you a lot of time, especially if you have like bulk, with bulk work, basically.
Right. Yeah, no, this is exciting for sure.
All right, that's good.
Yeah, Chris, since you're doing pretty much this exact process on your end, I'll send you the manual that we wrote that pretty much documents all of this. And then, like we said, we have videos as well. And if anyone else is interested and in a similar situation to Chris, please let us know and we'll send you all of this documentation. All of this is, on paper, and like we said, we'll also be making a video.
Thank you.
All right, so let's go back to the next lab, which is going to be utilizing or building basically the DI object and the attributes from scratch. This is if you're not going to use AutoBuild. All right, so going back to our production galaxy, the first thing to do here is to start by creating, the DI object. And I'm going to do that using the device integration. We're going to use DDE SuiteLink client. You have an option of using OPC client or DDE SuiteLink. And I'm going to go ahead with the DDE SuiteLink, and I'm going to I'll start by creating a new instance. I'm not going to do that right now, but I've already done it. So this is how you do it. You go to new and then click on instance and then call that new DI object the name that you're interested in. Mine is called AB_PLC. I'll double click on that so you guys can see the configuration. And the configuration is actually very, very simple. I'm going to start with the server node because I have the communication server sitting on the same local machine, which is the 121 machine. The server node is going to be localhost, and then the server name is going to be ABCIP. This is where you would put OI Gateway or ABCIP or Omron or what is the other one? SI Direct or whatever server name that you guys are utilizing. But in this case, we're utilizing the ABCIP, so I'm going to put that there. And then the topic is going to be topic 4. We've used multiple topics in this galaxy for the other PLC. So I'm using topic 4. And that's it. There are three fields to configure here in the DI object. And it's the communication protocol is going to remain as SuiteLink. So I'm going to save and close that. This is my DI object. This is the point that communicates with the ABCIP server in the SMC. So from the SMC, just to give you an overview of the data flow from the PLC to the ABCIP server in the SMC, and then to the DI object in system platform, which is the AB_PLC. I am placing that under an app engine that has to sit under an app engine. Obviously, this isn't this specific galaxy is not a practical situation. You usually won't have your engine sitting in the galaxy itself from the GR node itself. They would probably be sitting under the AOS. But just for the sake of simplicity, we're doing everything in the same platform here. So this is the step of creating the DI object. If you guys have any questions, please fire away. Otherwise, we can move to the next step, which is creating the template and the instances. All right. So the next step, now that we have a DI object, we need to create a user-defined template. So we're going to go to user-defined and say new and create a new derived template. And I'm creating a template because we have 2 instances. So I don't want to create an instance and then have to change everything multiple times in all of the instances. This is the idea of system platform, is that it's templatized. So you can create a template and then you can make all the changes and deploy the changes in the template, and it will force them down to the instances. So at this point, we create a new template or a derived template. And in my case, I've already created this valve template. I don't want to go through the whole process now. It's going to take time to create the attributes and everything. So just to show you how it's done, I've created this valve template and I added all the attributes that I'm interested in. I have 8 attributes here. You have the auto command, auto permissive, auto status, and then the closed and open indicators and status, and then the manual command. You can see here that I've enabled some of the features. I've enabled the IO and the history features, and I've also included the graphics here, we're going to go through how to build this symbol here also. All of these attributes must match the data type as in the PLC, of course, and they have to match the name. So you don't have to do the mapping basically. And what I mean by that is AutoC is exactly the same as it is in the PLC program. That this specific attribute corresponds to an element in the PLC program that is called AutoC. Or auto permissive in the exact same spelling. So make sure that these correspond to the same PLC elements, so you don't have to do the mapping, basically. You don't have to, otherwise you're gonna have to come here to the SMC and do this device items mapping. You're gonna have to tell it what is the name in the system platform and what is the item reference in the PLC. So to avoid that, just make sure that you have a naming convention. So once we are done with configuring our template, we're happy with this valve template. I'm going to save it and close it, and then create 2 instances out of this template. So I'm creating instance 1 and instance 2, resulting in VLV001 and VLV002. And note here that also the instances names are corresponding to the same instance names as in the PLC program. Let me just go back there. So as you can see here, we have this VLV 001 and VLV 002. So all of these attributes or elements in this case in the PLC, like this one here. So VLV 001 dot auto permissive. I'm going to have the exact same name for that attribute in system platform. All right. So now that we've created the 2 instances, and they are just copies of the template, basically. They have the same attributes, same names, and then because we deployed this template, they've also inherited the graphics. Now we have created the 2, the template and the 2 instances. It will take time if you have tens and hundreds of templates and instances. Obviously, that's where auto build saves you time. But if you're comfortable with doing it this way, this is also possible. So now we have a DI object and we have the 2 instances. We created a topic under this DI object, the AB underscore PLC, and we created topic 4, and then we placed the 2 instances under this topic. And this is basically where the communication takes place between the server and the DI object. So now here I have all the attributes listed under this topic, which are related to valves 1 and 2. And I'm going to validate these references to make sure that I'm receiving all the information from the PLC. And as you can see here, nothing has failed and all of the attributes are validated. This is reading real-time data from the PLC. If it fails, it would be giving you red fields here. It won't be giving you any information. So this is about creating the DI object, the template, and the 2 instances, and all the attributes. At this point, we are ready to visualize. Again, this is pretty simple application with just 2 instances and few attributes. The next step would be to create the visualization part, is to go to the graphic toolbox and create a new profile or a screen profile, and then create a screen layout, and then create a symbol. And this is what every OMI screen or every OMI application consists of. So just to show you how to configure these and what each one of these mean. So a screen profile is where you decide how many screens you have for your application. You decide the orientation and the resolution, whether this is going to be a touch screen, whether it's going to be multiple screens or 1 screen only. So our screen profile for this specific application is only going to use 1 screen. So I'm happy with how this looks like, and I'm just going to leave it the way it is. So this is my screen profile. And then we created a layout, and I call this layout valve underscore IOS. And again, this is created by right-clicking on the project and saying create a new layout. So I have multiple layouts here for other projects, but for this specific project, we're interested in the valve layout.
specific to OMI, not HMI, right?
Sorry, someone is asking. I can barely hear you. Sorry, Chris?
Yeah, that's me. Sorry about
Sorry.
that. Is that
Yeah,
better?
it's all right.
This
Yeah,
is specific to OMI, not HMI, correct?
this is this is OMI, not in touch.
Okay, thank you.
Yeah, sure. By the way, we have an OMI workshop coming up soon, I think in April or beginning of May. So if you guys are interested, it's a 3 hours hands-on workshop on OMI that you can register on. If you're interested, just let us know in the chat or communicate the same to your sales representative, and they'll make sure that you're invited to that. I'm going through this very, very quickly. We spend way more time talking about these elements in OMI, basically, in that workshop. All right, so this is the layout. I've decided that I have few panes in this layout. So I've decided that I'm gonna have this pane that includes a navigation tray to navigate through my model. And then I also have another navigation control here. All of these navigation controls are out of the box. All you need to do is to come here and search for them. These are built by OMI, I mean, out of the box and OMI, and this is one of the best things about it. Are these controls. So there's the historian client control, and then there's the alarm control, the navigation control, there are multiple ones that you can just drag and drop into your panes. Panes are basically specific areas that are dedicated for specific content. And then the biggest pane that I have here is the pane where I'm using to display the valve symbol. We're going to go through how to build the valve symbol also. So this is the main pane. It just includes the valve auto command and the valve manual command IOs, and then it includes the other 6 IOs that were including in these instances. So that's about the layout. You can always add more panes, you can add more information. But again, we go into a lot of details in the OMI trainings and the OMI workshop. So that's that for the layout. I'm going to close this without saving it because I'm happy with the way it looks right now. And then the next step would go to create the symbol. And in order to do that, again, we're going to right click on that graphic toolbox, which is the project toolbox, and then we're going to create a new symbol. So what I'm going to do here is going to double click on the symbol, which is previously created, where we have linked all of our attributes. All of these are just text boxes, so you can utilize this tools box here to create these text boxes. And these are embedded symbols or the SA text entry 1, but basically you can get this element from, you can embed this element, you can look for it here basically. I think it's somewhere in the situational awareness. It should be here in situational awareness, but it's the SA_ text entry. And the way to configure this or to link it, what I'm doing here is we're using relative referencing. And what we mean by that is where basically the PV or the value is going to come from a relative reference related to that template, which is me dot something. So in this case, it's going to be me dot manual command, right? And me dot stands for either valve 1 or valve 2. And the way to utilize this is by embedding the symbol in the template and then deploying the template. And when you move in the OMI screen, when you move between the templates, or between the instances, it's going to change this me dot to either a valve 1 or a valve 2, or if you have 20 valves, it's going to go up to valve 20. So you don't have to create 20 symbols for your 20 valves. And that's where we use relative referencing. They talk about this into a lot of details also in the training. So if you're interested in this topic, I suggest that you join either the OMI training or the system platform training. So this is what we're doing here, just to show you another one. For example, this is the manual command, and then the auto status will have the same thing, but it's going to be me.autos, right? And again, this me dot is going to translate into VLV001 or VLV002. And this is what we did for the other 8 or the other attributes. Again, these are just text boxes here. And that's it about the symbol. Once we're happy with the symbol, we can save and close. And what we need to do then is to go to the main template, which is the VAV template, and embed this symbol in the VAV template. And that's what we did right here. So you can see this is the AB_VLV symbol, the one that I just opened. And this is how it looks. And then because we're using relative references, it's gonna resolve into the 2 instances that are derived from this template. And finally, the next step, unless you guys have questions about what I've just done, it's pretty straightforward. It's very, very simple program, basically, in System Platform. But if you have any questions, please go ahead and ask. Again, all of this is mentioned in the manual. All of these steps are in the manual also. All right, so the next step then would be creating the view app. And in order to do that, I will look for the view app. So this is the view app template. I need to right click on it and create a new template or derived template. I did that here. This is the view app_AB for the Allen Bradley PLC. So I'm going to double click on that. And what you need to do for any view app is you need to decide what screen profile you're going to use, which we've already created, and then which layout you're going to use for this view app. So I told it that I'm going to use screen profile 1, and then I told it that I'm going to use this valve_IOs layout. And this is how it looks like in the view app. Now you can preview it here, or you can use the Aviva OMI manager, and that's what we're going to do. So after you're happy with, once you're done configuring your view app template, you can create an instance out of that template, and that's what we did here. This is view app_AB_001. It's derived from this view app template. And before we open it, I'm going to deploy it. Let's hope this works. All right. So now our view app is deployed. All we need to do is just to go to the Aviva My Application Manager. You can see all of the applications that we have created in this galaxy. And I'm going to launch this app. Just a question, everyone's asking for the auto build video or for the workshop video in the chat. Pierre.
So yeah, let's specify that, guys. So right now we have a manual that has everything that was discussed today, including auto build, in written form, and so we can send that out. We will also be recording, this workshop's being recorded. So all of this that we went over today will be also in video form as a recording of this workshop. And then we are planning on recording a condensed video that's essentially an abridged version of this workshop without the breaks, without the questions or anything. That's straight to the point, and we can send that out as well. So when you guys are requesting this, at this time, we can send you the manual and the recording of the workshop. And then we'll keep a list as well if you guys are interested in being alerted when the condensed video is created.
All right, thank you, Pierre. By the way, for anyone interested in the Modican PLCs connectivity, we have had a workshop and we have a condensed like 10 minutes video that takes you through utilizing Modican communication driver and the connectivity between the Modican PLC and system platform. If you're interested in that, please go ahead and ask for it in the chat and we'll make sure to send you that as well. But I think it's already on our YouTube channel. All right, so we've launched the the Aviva OMI Application Manager View app, and this is how it looks like. It's reading values from the PLC. As you can see, some of these values are changing, like this. I think the closed status and the open status are changing, and the auto permissive is also changing, as you can see here. The navigation tree goes through our model plan, basically. So let's say I'm gonna go and see valve 1 first. So this is valve 1, and then if I want to switch to valve 2, I can see valve 2 attributes also. There's no difference here between both of them. They look exactly the same. They're using the exact same symbol. And because they're actually using the exact same simulation program, so they're simulating the same values, but in reality, they're not going to be the same values, and they actually might even be different devices. So I think this brings us to the end or a conclusion of this workshop. We went through the basically 6 steps. The first step was working or programming the PLC. The second step was installing the ABC IP server, and then configuring the ABC IP server, and then utilizing AutoBuild to create templates and instances in system platform. And then another step, which is a parallel step, you could do either or, the AutoBuild or create things manually. We created things also manually. We came here to system platform, we created the instance, the template, and then the instances. We configured the attributes, and then we configured the DI object, and then we configured the different sections or different elements of the OMI application, starting with the screen profile, the layout, the symbol, and then the view app. All right.
So now's a good time to ask, guys. So since you know, this condensed video that we're going to be creating, you know, we could definitely use your guys' feedback here. Would you guys like to see a video that goes over everything we went over here today, including the system platform setup that Alcanza went over and the creation of the OMI app? Or would you guys like to see just a video going over the configuration of the ABC IP driver and only that, straight to the point? We can really go any direction here, so it's based on what you guys would find useful. All of it? Okay. Sounds good. So basically it'll just be just like the recording of this workshop, but you know, without the fluff of the breaks and the questions or anything like that. Just the material from start to finish. Yep, and that's a great suggestion, James. We can add some timestamps as well. Thank you.
All right, actually, I'm going to look for the Modicum PLC video and just send that to everyone in the chat. So basically, we have less tasks to do later on. But
yeah, I think, yeah, honestly, why don't we just we can just write. We'll send an email to everyone here and include all the material for both workshops.
Yeah.
That way, you know, even if you didn't request it, everyone will have everything.
Yeah. So this is the video for the Modicum PLC. And we'll make sure to send you the manuals also.